We're asked to find sine and cosine given, sine and tangent given this, given that cosine of theta equals 1/3, and then cotangent theta is greater than 0. So a lot of information coming at us here. But what you want to actually start with is this information over here, because an angle theta can only be in one of these four quadrants, or it could land on one of the axes, right? But it can only be in one of those four quadrants. And we're told that cosine is a positive 1/3. And so there's a mnemonic device you can use. All students take calculus, where A represents all trig functions are positive here. S represents just sine and its reciprocal cosecant are positive here. T is tangent, just tangent and cotangent are positive here. And C is cosine, so just cosine and secant are positive there. So if cosine is positive, then it could be here where they're all positive, or it could be here where cosine's positive. And then they told us cotangent is positive. Remember, cotangent and tangent go hand in hand because they're reciprocals. So if cotangent's greater than 0, then that could be either here or here. And so the place of those two facts meet, where cosine is positive and where cotangent is positive, that's only here in this quadrant. Okay? If it said less than 0, then cotangent would have to be negative, which means cotangent is negative here and here, and the intersection would be down here for this triangle, right? Because this is where cotangent would be negative, but where cosine is positive. Tangent and cotangent go together, because remember that C stands for cosine. Okay, but ours is positive, so they're both positive right here. And now we don't know what theta is, but we know what the adjacent divided by the hypotenuse is, because cotangent is the adjacent divided by the hypotenuse. So not the opposite, nothing to do with the opposite of our angle theta. The adjacent is 1 and the hypotenuse is 3. So it's not the unit circle, but that's okay. We can figure out what this missing side is using the Pythagorean theorem. Okay, so 1 squared is 1. 3 squared is 9. So to get b by itself, we want to subtract that 1 from both sides. Then we want to take a square root to cancel out a squared, so we'll want to remember positive or negative square root of 8. But since we're dealing with real measurements, I think we can just drop the negative. We can definitely drop the negative, actually, because this is the positive side of the x-axis. You know, this is y is positive 1, y is positive 2, so this is a positive number. But this radical can be simplified. Okay, if you can divide out a 4 or a 9 or a 16 from a radical, do it, because you're simplifying the radical when you do that. Right? I took 8, I divided by 4, so that gives me 4 times 2. So the square root of 4 is 2, and the square root of 2 is 2. Okay, so we found out this missing side is 2 square roots of 2. And now we have all sides, we can tell them what the sine ratio is. Sine of theta is the opposite divided by the hypotenuse of the triangle. So the opposite of theta divided by the hypotenuse. So tangent of theta, that's the opposite divided by the adjacent. So 2 square roots of 2 divided by 1 is just 2 square roots of 2. So there's our two ratios that we wanted.